Hey everybody, we're going to be looking at 5.5 today, solving logs. So before we get into that, I really want to talk about some things that we're going to need for today, and that's specifically solving quadratics. So we did this way earlier in the beginning of the year, so just in case you did a brain dump, let's make sure that you still remember how to do these. So first thing to remember with solving logs or solving quadratics is that we need it to be equal to 0. I'm not equal to 0 here. I'm equal to 1. So I need to get it equal to 0. So anytime you have a quadratic, and I know I have a quadratic because there's a squared, an x squared, I need to get it equal to 0. So I need to move everything to one side. And then factor. X squared, 3x, 2x, 6. Take an x out of both of those, x, 2, and 3. Okay, so again, hopefully you remember how to factor / use quadratic formula. And if not, then it's a good time to review that. Okay, I'm equal to 0, which means x needs to be equal to -2 or -3. Okay. So for the actual lesson today, we're going to be looking at solving logs. So we have a bunch of rules we need to follow, but really it comes down to using the tools that we've been using so far. Okay, so remember in the last unit, if I had something like this, and I wanted to find out what that was equal to, we set it equal to x. And then we exponentiated both sides, and we said 4 is equal to 2 to the x, so x must equal 2. Okay, and that worked really nice when I had numbers that were nice, like 2 and 4. If I don't have things that are nice, though, this trick doesn't really work for us. So after today, we would be able to solve something like this. Now, on this page, there are really two things that are super important, and that's the extraneous solutions part. So remember, we have domain restrictions when we're dealing with logs. So I can't take the log of a non-positive number, meaning no negative numbers and no zeros. So we are going to want to check any answer today when we have a log, or start with a log, I should say. Okay, so the goal of solving any equation is to get x by itself. So let's get x by itself. I'm going to exponentiate both sides by 4 because that's going to get rid of that log for me. Again, I'm trying to get x by itself, so I'm trying to get stuff away from x. 4 to the -1. Again, just keep moving stuff away from x. So x equals 4 to the -1 plus 5. Okay, and if I throw that in the calculator, I get 5.25. Okay, now again, I started with a log, so I want to check for extraneous solutions. The way you do this is you just take whatever you got, plug it back on the inside. If you get a positive number, great. If you get a negative number, then it's extraneous and it doesn't exist. Okay, 5.25 minus 5 is positive 0.25. So since it's positive, that's okay. So there's my answer, 5.25. Okay, now the thing we want to make sure we really understand is really make sure that you did finish the 2 assignments from before, because you really need to understand condensing, especially for what we're about to do. Condensing is the step 0 on all these problems. So step 0, we want to condense. Okay, so if I can combine things, I should. Because the reason I don't want to just start by exponentiating both sides is I would be exponentiating the whole side, and e to the all of this, I can't really do anything with. Okay, so I do want to combine these. And since I have addition, it's just going to turn into multiplication. So x minus 3 times x plus 4. Okay, and then condensing on this side, remember I can take that 3 and throw it up as an exponent. And I do want to put it up as an exponent for this next step. Okay, now I can exponentiate both sides. The e and the ln's cancel. And I'm left with x minus 3, x plus 4 equals 2 to the 3rd, which is 8. Okay, taking this, boxing it out. So x minus 3, x plus 4, x squared minus 3x plus 4x minus 12. Because again, this is going to turn into a quadratic. If it was already equal to 0, that'd be really nice, but it's not. So we do need to deal with that. So x squared plus x minus 12 equals 8. Again, getting everything on the same side so we can factor. X squared plus x minus 20 equals 0. Okay, factoring this out, again, you should remember how to factor. If you don't, please go take a minute and go rewatch the video on factoring. X minus 4 equals 0. So then x needs to equal negative 5 or 4. Okay, now again, I started with logs. Okay, it's a special log, it's ln. It's the natural log, but it's logs. So I want to check and make sure these work, and I need to check on all of them. So I'm going to plug negative 5 in here. Okay, negative 5 minus 3 is negative 8. So that answer is no good. Okay, I need it to be positive. And it's also no good for this one. Okay, it only needs to be no good for 1 for it to not work. Okay, and then 4, let's check 4. 4 minus 3 is 1. 4 plus 4 is 8. So 4 is okay. So then x is equal to 4 and only 4. Okay, negative 5 was extraneous. Okay, now going the other direction, if I start with exponents, I'm just going to log both sides, just like we've been doing. Okay, again, today there's not really anything that's new. It's just kind of bringing everything back together. Okay, log 2's cancel and the 2's cancel. So I'm left with x plus 3 equals 2x minus 9. Then we're at an 8th grade problem, minus x. 3 is equal to x minus 9 plus 9 plus 9. So x is equal to 12. Okay, and I don't need to check for extraneous solutions since I did not have logs. I had exponents. Okay, exponents are never going to cause me problems with domain restrictions. Those don't have domain restrictions. Only logs do. Okay, so we don't need to check it for exponents. We do need to check it if we started with log. I know we used a log, but we did not start with a log. Okay. Now, on the last one, it was really nice because we had 2 and 2. Okay. Problem is here we have 3 and 9. Okay, so I could take log 3 of both sides, but that's not going to help me with the 9. And we could try log 9, but that's not going to help me with the 3. So what we need to do is we need to change this so they are the same base. And you're going to see one today in your work where it's 5 and 25. So just watch out for that. Okay, well, I can rewrite 9 as 3 squared. Okay, so then 5 and 25, obviously we would write 25 as 5 squared. Okay, at this point I have a power to a power. So 3x plus 1 equals 2 times x. It's going to be 2x. 2 times negative 1 minus 2. Power to a power, we multiply. Log both sides. Now they're the same. Okay, so we really want them to be the same before we start logging both sides, because then things aren't going to cancel nicely. Boop, 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 boop. Left with x plus 1 equals 2x minus 1 minus x minus x. 1 is equal to x minus 1. Sorry, 2. Plus 2 plus 2. X is equal to 3. Okay, and again, we don't need to check for extraneous because we did not start with logs. Okay. Same idea here. To exponentiate. Okay, now I did start with logs, so that tells me I do want to check later for extraneous. 8x plus 23 equals 2 cubed, which is 8 minus 8 minus 8, x squared plus 8x plus 15 equals 0. Factoring that out, I'm going to get x plus 3, x plus 5. Okay, and if you want to do a quadratic formula, you'll get the same answers. X is equal to negative 3 and negative 5. Plugging those in. I only need to plug it in on the inside. I'm going to get negative 5 squared plus 8 times negative 5 plus 23. Okay, and that does in fact equal 8. And then I also want to check negative 3. Okay, 8, negative 3 plus 23. Okay, please remember these parentheses around the squares because that does get rid of that negative there, which is also equal to 8. Okay, so both of these are positive. So both of these solutions are okay. Okay, we do want to be careful, especially on ones where we have a squared or we have to do factoring or quadratic formula. We really want to be careful on those ones to check for those extraneous solutions. Okay, on this one I did not have any. On the other one I did. Okay, the last type of problem you might see, and it would be the same for the log, okay, something like this, where you only have an x on one side. And these are the nice ones. These are the quick ones. Okay, so I take, log base 11. Log base 11, both sides. Because again, I want to get x by itself. And wow, x is already by itself. So I just need to figure out what this is. Remember, I can rewrite that in my calculator as log of 30 over log of 11. I don't remember what that one is off the top of my head. 1 second. So log of 30, close that parentheses. Log of 11, close that parentheses. I get about 1.418. Okay. For the homework assignment, this one is going to be on big ideas. Please skip number 10 if you're in my regular classes or my virtual classes. If you're in the honors classes, I do want you doing that one. It's a little tricky, but I think you guys can do it. And then obviously for the regulars, if you want to attempt it, that's perfectly fine. But you do not need to do that one. I will delete that one later. Okay, so again, please make sure you are coming to RTI time before the test preferably, and make sure you're keeping caught up. Again, we're with this being the last quarter, we don't have time at the end of the quarter to try to cram everything in. So please be keeping up. Please be coming if you need extra help. And I will see you guys next time.